Hi everyone, welcome back. So far we have covered all the data types in C++, but right now we will discuss pointers and references in depth. Previous session I explained the concept behind pointers and also the concept behind references. Now we will see the necessity and then later the syntax of pointers and references. Um, Generally, when you want to pass a data to another part of your code, for instance, if you want to pass a data from main to another function, you have two options. You can either copy that data and send a copy of that, or you can send the address. You can send the address of that variable to your function to another part of your program. But sending a copy, especially when you have a large data, is not efficient. So in this case, you need to pass the address of that. And for passing the address, we need a type of variable to store that. And that type is pointer. The second reason is that the necessity of having a pointer is pointers are reusable. Unlike references, you can have a null pointer at the beginning. You can initialize null. You can initialize a pointer with null, and then later store the address of a variable, and later change that address to the address of another variable. And the third one, but the necessities are not limited to these three, is pointers can be null. As I said, you can have a null pointer, and whenever you need to store an address in your program, you can use that pointer to store that. About the references is references are, you can think of them as an alias of a variable. They're exactly the same, and this allows us to work with references very easily along the program, and we don't need to use dereferencing, and the references are behaving exactly the same as if you are working with the original variable. And the second necessity is when you are dynamically allocating a memory block on the heap, you won't want to lose the address of that block, because if you lose that address, you no longer are able to free that block of memory up, and then you have a memory leakage. So in order to store the address of a memory block, in order to have the address of that memory dynamically allocated memory, we can use reference, because when you declare a reference, you have to immediately and at that line initialize that as well, and later you cannot reuse that reference. You cannot change that reference to referring to another variable. So these are the necessities, and right now we will cover the syntax behind syntax of pointers and references. Right. Again, I have the student class. I copied from the previous code that we have for student class. Has two attributes, ID, GPA, and has two functions, print and set ID, GPA. All right, you remember we had different types of data. Different data types. We had user-defined, built-in, and derived data types, and we can refer or point to any of these data types, almost all of them. Right now we will see them one by one. The first part is primitive data types like int, float, bool, double, char. I will explain how can we refer or point to an integer, and then you can change this into bool or float or any other primitive data type and have the same behavior, and they are exactly the same. So I will cover only integer here, and in this line 50, I'm initializing an integer called integer num and assigning 7 to that. And later in the next line I have a pointer. By using a star, I will tell the compiler that this is a pointer, and int means the type of data that IPTR is pointing to. And for the assignment, I'm using ampersand sign for getting the address of integer num and assigning that address to IPTR. So right now IPTR's value is the address of integer num. Okay, this is how you can refer to how you can point to an integer. And the way that you can refer to an integer or have an alias is by using ampersand sign. Ampersand and then the name of that data type and the name of that data type that you are referring, and you have to initialize that in declaration as well. You cannot have the declaration first and then initialize that in another line. And and the next line is another way of having an alias, having a reference. If it's new int 8, I'm allocating I'm dynamically allocating a memory, an integer with value 8 on heap, and I'm passing that variable to iref2. And iref2 right now is a name of this variable, a star parentheses new int 8. Alright, this was the first part, pointing or referring to primitive data types. The second part is pointing or referring to user-defined types. First of all, we don't refer or point to enum or unions. It's not common. And also referring to a structure is exactly, or pointing to a structure is exactly the same as pointing or referring to a class. So here I will only cover pointing, referring to a class or to a class object. Line 63, initialization or declaration of a std student object called std, and then here I'm declaring a pointer to a student object, to a student class, and later sptr is assigned with the address of st object. And again, for getting the address of an object, you can use ampersand sign. But you remember when we had a class, when we had an object of a class, we could use dot operator for getting access to the attributes, getting access to the public attributes and functions. And here I'm doing exactly the same. std.printinfo, it prints the info of a student object, and then but I can also use the pointer that I have here, sptr, for doing exactly the same thing, for getting access to the public attributes or public functions. But there is a subtle difference here. First, if you want to use dot operator, you have to dereference this pointer and then use dot operator. Or another way for simplifying the syntax is using pointer and then arrow operator to call the functions of that object that sptr is referring to. Alright, let's run this part and see what will happen. You see, the first line is a student with ID -1 and GPA 4 because we didn't change the default values, and the default values of ID and GPA are -4, -1 and 4. So here we will have -1 and 4, and then I'm printing SPTR, dereferenced SPTR with dot. Again, I will have the same behavior. Another way is using arrow operator. Again, I will print the info with the same behavior. And okay, for referring to an object or having an alias, we can again use ampersand sign, and then the type of that object or data that we are referring to. In this case, is the student class. But for the reference, as I said, the reference behave exactly the same as the original variable that you have, and you can write your code as if you are exactly working with the name of your original variable that you have. So that's why we don't need to dereference or use arrow here for reference, and we can simply use dot for printing the info. All right, so we covered pointing and referring to an object of a class. Next, we will see pointing and referring to derived data types. And for derived data types, we have four options: array, functions, pointers, and references. So in general, we have 8 possibilities when we want to explain pointers and pointing or referring to array, function, pointer, and reference. But we don't have all of the, but not all of those 8 cases are valid. In C++, we don't have a reference to a reference, for example. So and also other things are not really common other cases. So here we only cover 2 important cases here, which is the first one is pointer to pointer, and the second is pointer to an array. Pointer to a pointer. Imagine you have a pointer that is pointing to a number. You can have another pointer that is pointing to that pointer that is pointing to that number. I know it's a little bit complicated, or no, it's not complicated, but it's a little bit strange. I can explain that here, or maybe here. So you have your pointer here called, let's say, what was the name that we chose? Pointer. Okay, I will change the name of this. Change the name of this to pointer. You can simply have another block of memory, another pointer, int a star means it is a pointer to another pointer, and int means the final the type of the final variable that all of these pointers, this chain of pointer is referring to is int. And then you have the name of your variable. Let's call it p2p, pointer to pointer. So this p2p has its own address, and the value of this p2p is the address of this pointer. So you have a chain of pointers that are finally pointing to data, or they can also point to null. But the concept is, yes, so the concept is we can have a chain of pointers, and no one prevents us to have this behavior, to have this option in C++. And we will see the use case of pointers to a pointer later in another video. All right, so for now I have a variable in num equals 7. We can think of this variable as num with value 7. And the next line I have declared another pointer called pointer and initialize that with the address of num. And the next line I have a pointer to a pointer which has which initialized with the address of this pointer that I had before. And for printing the data, the data stored in the last step of that chain of pointers, you have to again dereference them. But for dereferencing, because it's a pointer to pointer, we have to use a star 2 times. And yeah, when you print that, when you run this code, you will have the value of that final variable, which is 7. All right, so next, this was the first case, pointer to a pointer, and the next case is pointer to an array. All right, right now we have a pointer called an array called iArray with size 5 and initialized with 0. I've printed the array here, printing elements of array, all of them are 0. And the way that I can print the elements are by using the name of that array and then using the square brackets for going jumping from the first element to the next one, or to a specific element of this array. And yeah, this is how can we initialize and print the values of an array. And the next line in this part, I'm declaring a pointer, and this pointer is referring to integer because our array is has an integer type. And notice that I'm not here using ampersand sign, but before, when I was pointing to a number, I was using ampersand sign. The reason is an array array is an address by itself, and you don't need to use ampersand sign. So right now this AR_PTR is pointing to our array, and I can use AR.PTR with a square brackets to get access to the elements of that original array. And yeah, that's everything about the syntax, and we don't need to cover anything else. I think that's everything that we needed. And the last point is this array has the address of the first element in the array. So when you are passing the address, you are storing the address of the first element. But since arrays are reserved on the memory contiguously, you don't need to store the address of all the elements. When you have the address of the first element, you can, for instance, if your array contains of integers, the first the address of the first element, and the address of the first element is given, you can multiply the address of the, you can add 4 to the address of the first element and get the address of the second element, because integer takes 4 bytes on your on memory, and this is why we only need the address of the first element in the array and not all of them, because they are stored continuously. All right, everyone. That's pretty much it. I will explain the scope in the next video, and bye for now.